The cosmos is vast, stretching far beyond the limits of our imagination, filled with countless mysteries waiting to be uncovered. And sometimes, against all odds, a visitor from another star system appears on our doorstep, crossing unimaginable distances to reach us. On July 1, 2025, astronomers using the Atlas telescope in Chile spotted a faint, fast-moving object, 3I/Atlas, streaking across the night sky, its presence barely noticeable at first. This was only the third confirmed interstellar object ever detected, following in the footsteps of 1I Oumuamua and 2I/Borisov, both of which had already rewritten our understanding of the solar system's boundaries. Archived images revealed that 3I/Atlas had been quietly approaching since mid-June, a silent messenger from the direction of Sagittarius, slipping through the darkness unnoticed until now. The discovery electrified scientists around the world. Here was a pristine relic from another star, a rare and precious opportunity to study material not born in our solar system, but shaped by the forces of a distant sun. 3I/Atlas is a cosmic message in a bottle, carrying secrets from a place with its own unique history and chemistry. A world we may never see but can now glimpse through this tiny traveler. Every available telescope, from backyard setups to the world's largest observatories, was quickly trained on this fleeting visitor, as astronomers scrambled to gather every possible detail. The race began to learn as much as possible before it slipped away forever, knowing that such opportunities are vanishingly rare and may not come again for decades. What is it made of? How old is it? What propelled it here? And what stories does it carry from its home system? These questions echoed worldwide, sparking debates and fueling new research. 3I/Atlas's arrival is more than a discovery. It's an invitation to explore the unknown, to reach beyond our own solar system and imagine the possibilities that lie among the stars. For a brief moment, we get to read a page from a book written in a different cosmic language, reminding us that the universe is full of wonders still waiting to be found, and that every discovery brings us closer to understanding our place in the cosmos. 3I/Atlas stands out for its astonishing speed, over 130,000 miles per hour, a velocity that's almost impossible to comprehend. To put that in perspective, it's more than 50 times faster than a speeding bullet, and nearly twice as fast as the fastest spacecraft ever launched from Earth. This incredible pace means it's not just moving quickly by human standards, but is among the fastest natural objects ever observed passing through our solar neighborhood. Its speed is far above the sun's escape velocity, the threshold needed to break free from the sun's gravitational grip. Most comets and asteroids we see are bound to the sun, but 3I/Atlas is moving so fast that it's just passing through, never to return. This confirms it's not from our solar system, but a true interstellar traveler, an object that has journeyed across the vast distances between stars, carrying secrets from far beyond our cosmic backyard. Early estimates put its size at up to 7 miles wide. Hubble later refined this to about 3.5 miles, still the largest interstellar object ever detected. To imagine its scale, picture a mountain drifting silently through the void, dwarfing most comets and asteroids we've ever studied. Its size means it's more likely to have survived the harsh journey through interstellar space. Smaller objects would have been eroded or destroyed by cosmic radiation, collisions, and the relentless forces of deep space. But its age is even more remarkable. Scientists estimate it could be up to 8 billion years old. That means it formed long before our sun and planets even existed, making it a relic from a time when the galaxy itself was still young. That's nearly twice as old as our solar system, which is only about 4.6 billion years old. 3I/Atlas has witnessed cosmic events and galactic changes that we can only imagine. 3I/Atlas is a time capsule from an earlier era of the Milky Way, carrying physical samples from a period we can only imagine. It's a messenger from a forgotten epoch, offering us a rare glimpse into the galaxy's distant past. Its very existence hints at the chaotic processes that shaped young star systems, where massive planets could fling objects out into interstellar space, setting them adrift for eons. Its journey likely began with a violent ejection from its home system, perhaps by giant planets. Such a dramatic start would have sent it tumbling into the unknown, beginning a voyage that would last billions of years. Since then, it's drifted through nebulae and past countless stars before arriving here by chance. Along the way, it may have encountered cosmic dust, radiation, and the gravitational pull of other stars, each encounter leaving subtle marks on its surface. Its arrival lets us study the building blocks of other solar systems and glimpse the galaxy's ancient past. By analyzing its composition, scientists hope to unlock clues about the environments where it formed and the forces that shaped it. 3. I/Atlas isn't just a rock, it's a historical artifact of cosmic proportions. It's a silent witness to the birth and evolution of stars, planets, and perhaps even life itself. Its combination of speed, size, and age makes it a scientific treasure, a rare visitor that connects us to the broader story of our galaxy and the mysteries that still await discovery. Most astronomers agree, 3I/Atlas is a comet. As it nears the sun, its icy surface warms, releasing gas and dust to form a glowing coma and a faint tail. Classic comet behavior. Spectroscopy of the coma reveals the chemical makeup of the nebula where it was born. This fits our understanding of how solar systems form. Giant planets can fling icy bodies into interstellar space. The galaxy is likely filled with trillions of such exiled comets. The fact that we've now seen 3 suggests this process is common. The natural comet hypothesis is grounded in decades of observation and planetary science. 3I/Atlas, while extraordinary to us, is likely an ordinary object in the galaxy. Seeing it as a comet connects us to the wider universe, showing that familiar processes shape worlds everywhere. Its journey reaffirms that the laws of nature are universal. Science thrives on skepticism and bold questions. Harvard's Avi Loeb suggests we consider the possibility that 3I/Atlas might be artificial, perhaps a probe or derelict spacecraft. He points to a Hubble image showing a glow ahead of the object, unusual for a natural comet. Loeb speculates this could be a central light source, maybe even a power system, and notes the tail is fainter than expected. Could this be a malfunctioning propulsion system, or just a misleading appearance? While most scientists favor the natural comet explanation, Loeb's perspective reminds us to keep an open mind. The universe has surprised us before. We shouldn't dismiss the extraordinary without careful evidence. The debate over 3I/Atlas is a classic clash between the familiar and the extraordinary. On one side, we have the comfort of established science, the patterns we've seen time and again in our solar system. On the other, the tantalizing possibility that something truly unprecedented has entered our cosmic neighborhood. Occam's razor favors the comet theory. It fits what we know, needs no new physics, and matches observed features. The comet explanation is simple, elegant, and consistent with decades of astronomical observations. It's the default answer, the one that makes the fewest assumptions. But the what-if question drives science forward. Every major discovery began with someone daring to ask if the obvious answer might not be the whole story. What if the anomalies, like the forward glow and faint tail, point to something new? Could these subtle differences be the fingerprints of an artificial object or just quirks of nature we haven't seen before? The alien tech hypothesis asks us to consider features that don't fit natural explanations. It challenges us to expand our imagination and not dismiss the improbable just because it's unfamiliar. Think of finding a strange object on a beach. Is it driftwood or something crafted? Sometimes the line between natural and artificial is blurred, and only careful study can reveal the truth. Both perspectives are valid starting points. Only data can decide. Science thrives on skepticism and curiosity, and both are needed to unravel mysteries like this. As more information comes in, especially from instruments like the James Webb Space Telescope, we'll analyze the gas and dust for clues. These advanced tools let us peer deeper, and with more precision than ever before, searching for chemical signatures or patterns that could tip the scales. If we find familiar cometary compounds, the natural origin is confirmed. It would reinforce our understanding of how comets behave and what they're made of. If we find something truly bizarre, the debate will shift. A single unexpected result could open up entirely new avenues of research and speculation. For now, scientists remain open, weighing evidence as it arrives. The process is slow, methodical, and sometimes frustrating, but it's the only way to reach reliable conclusions. The truth will emerge from careful observation, not speculation. Patience and rigor are our best tools in the search for answers. 3I/Atlas challenges us to question, test, and discover. In the end, it's this spirit of inquiry that pushes humanity forward, reminding us that the universe is full of surprises waiting to be uncovered. 3I/Atlas's journey is a cosmic flyby, shaped by gravity. Its hyperbolic path confirms it's just passing through, never to return. In August 2025, it's still far from Earth but closing in. Its first major milestone, a close approach to Mars in early October, offering a unique observation opportunity. Then it plunges toward the Sun, reaching perihelion around October 30th, likely triggering peak activity. After swinging around the Sun, it heads back into interstellar space. For a time it will be lost in the Sun's glare, but will reappear in December for final observations. Each stage offers new chances to unlock its secrets. On October 3, 2025, 3I/Atlas will pass close to Mars, an unprecedented opportunity. Mars orbiters like HiRISE can capture images far more detailed than anything from Earth. If we're lucky, we'll see the nucleus's shape, surface features, or jets of gas. Such images could settle the debate. A chaotic, cratered body would support the comet theory. But if we see geometric shapes or metallic features, the alien tech hypothesis gains ground. This Martian encounter is a new frontier, using our space infrastructure to study a visitor from another star. The data will be invaluable, offering our clearest look yet at this mysterious object. It's our best chance to move beyond speculation and see the true face of 3I/Atlas. Whenever a new object enters the solar system, safety is a top concern. But 3I/Atlas poses absolutely no threat to Earth. Its trajectory has been calculated with precision. It will never come closer than 1.6 astronomical units, over 150 million miles away. That's farther than the Sun itself. Our detection systems, like Atlas, are designed to spot potential threats early. The fact that we can track such a distant, faint object is a testament to modern astronomy. We can watch 3I/Atlas with wonder, not worry. Interstellar objects like 3I/Atlas are messengers from across the galaxy. They're the first physical samples we've received from other star systems. Studying their composition helps us understand the building blocks of planets elsewhere. 3I/Atlas, possibly 8 billion years old, is a piece of the early galaxy delivered to our doorstep. Its existence confirms that solar systems routinely eject material into interstellar space. This has implications for panspermia, the idea that life could travel between stars. Each new object refines our models and deepens our understanding of the galaxy's interconnectedness. These wanderers remind us that our solar system is part of a vast, dynamic universe and invite us to keep exploring.